Welcome to this session where we are looking at efficiency. This is the topic in physics, and we're going to answer these questions at the end of the coverage of this topic. These are exam questions which were asked. The first question was define efficiency. The second, a machine uses 500 joules of energy to lift a box, but only 350 joules is used as useful work. Calculate its efficiency. The third question was explain why no machine is 100% efficient. And the last question was a light bulb converts 60 watts of electrical power into 12 watts of light. Calculate its efficiency. Okay, so even before we can look at these questions, let's understand something about efficiency before we can tackle those exam questions. Okay, so we're looking at efficiency. What is efficiency? So when you're looking at efficiency, this is just the ability or the capacity of a machine to transfer energy usefully, okay? So you're saying ability of a machine to transfer energy usefully. So basically that is what efficiency is. Just the ability or the capacity of a machine to transfer energy usefully. Okay? Let's say you have a certain machine. This is the machine. Okay? You give this machine 120 joules of energy. Then this machine is able to do useful work of, let's say, 115 joules. Have you seen that this machine is not losing too much of the energy? Okay, it is not losing too much of the energy because you had to feed this machine with 120 joules and it is able to do a useful work of 115 joules. What can we say? This machine is what? More efficient. I'll give two scenarios here. Okay, this machine is efficient because it's able to transfer much energy into useful work. Now let's look at a certain machine. This is a machine. You feed this machine with, let's say, 100, or should I use the same value, 120 joules, and this machine is able to give or to do useful work or work output of, let's say, just 25 joules. Have you seen that this machine is losing so much energy? So because it is losing so much energy, we can say that this machine is not much efficient. Okay, it is not much efficient. Why are we saying so? Because just so much energy is being lost. Okay, now let's look at another definition, the other way you can define efficiency. So you can even say efficiency is just the ratio of useful work output, the ratio of useful work output to the total work input. Okay, and this ratio should be expressed as a percentage. We are saying as a what? As a percentage. So that's the other way you can define efficiency. Or we can say from that definition we can write the formula. We can say efficiency so this efficiency is denoted by a symbol known as eta. It is denoted by this symbol which is known as eta. So we can say eta or efficiency is equal to the useful work output over total work input. We said expressed as a percentage, right? So we're going to say multiplied by 100%. So you can express efficiency using this formula. Let's look at another definition. We can say efficiency is equal to the total energy input or the total useful energy output over the energy input. So we can say efficiency denoted by the symbol eta is also equal to total energy output you see, when you're talking about total energy output, we are just talking about useful energy output, okay, over total energy input. Over total energy input. And this, the entire thing must be multiplied by 100, okay? So you say multiplied by 100. This entire thing must be multiplied by 100. So you multiply the entire formula by 100, okay? So that is how you can calculate efficiency in a situation whereby you have the total energy input and also the energy output. So you can use this formula in order to come up with or to find the efficiency. So let's look at efficiency in terms of power. Let's look at efficiency in terms of power. How can you find the efficiency given the useful power output and also the total power input? So this is the formula you use. So I'll say efficiency is equal to useful power output over total power input over total power input, and this must be multiplied by 100%, okay? So you can use this formula to find the efficiency. Now we need to understand that no machine is 100% efficient, okay? No machine is 100% efficient, okay? It can only be so if maybe a machine is frictionless, or if a machine maybe does not lose any form of energy by heat, by sound, or maybe by light, or in any form, okay? But ideally no machine is 100% efficient. This is due to loss of energy, okay, in form of heat. Some machines are able to lose energy in form of heat. Some are able to lose energy in form of sound. Some are able to lose energy in form of friction. Some are able to lose energy due to light. For example, a bulb. When a bulb is lighting up, it can lose energy. It is able to convert energy into light. It's also able to convert energy into heat. So it's able to light up, and also it is able to produce heat energy. But you might be interested in light, okay? The use of energy is that which is converted in light, but as it is being lighting up, it is able to use that same energy and also convert some into heat energy. It is able to get heated up. So that will be just a wasted form of energy. Okay, so basically those are some of the formula you can use in order to find efficiency. Okay, so you can use or utilize rather those formulae. So let's look at these questions now. Let's answer these exam questions. But before we can answer these exam questions, let's look at examples. For example, let's say a machine. This is let's say an internal combustion engine. Then it has an input fuel energy of, let's say the input fuel energy of this internal combustion engine is let me use maybe 5,000 kilojoules. Then it produces a useful work output of 250, okay, or should I say 2,500 rather. So useful work output, okay, useful work output, useful work output. So the useful work output of, let's say, 2,500 kilojoules. Then you are asked to calculate what? Calculate its efficiency. How can you calculate its efficiency? So we have the useful work input, which is 5,000 kilojoules, and they will use that is the useful work output is 2,500 joules, that is kilojoules. Then the energy input is 5,000 kilojoules. So how can you calculate the efficiency? Okay, so I'll use the formula efficiency is equal to useful energy output, right? Useful energy output over total energy input multiplied by 100%. So this is the formula we are going to use. So let's now do the substitution. Okay, so let's do the substitution. So we're going to say this is equal to, so you know the formula, let me just get rid of this. So efficiency will be equal to, so the use energy output we are told is 2500 kilojoules. Then the total energy input was 5000 kilojoules. Then we are going to multiply this by 100%. So what will be the efficiency? So efficiency will be equal to, let's cancel 0 there and the 0, that 0 and that 0. Kilojoules, we'll cancel with a kilojoule. What is 25 divided by 50? That is just what? So we can say 25 into 25, that is a 1. 25 into 50, that is a 2. So it's just half. Half is 0.5. So 0.5 multiplied by 100, we are getting 50%. So 50% is now the efficiency. Okay? 50% is the efficiency. Now let's look at these exam questions. So the first question was define efficiency. We've already defined it, right? We've looked at the definition of efficiency, where we said efficiency is just the ability of a machine to transfer energy usefully, right? So that's the ability of a machine to transfer energy usefully. So that is how you can define efficiency. What's the next question? The next question is, a machine uses 500 joules of energy to lift a box, but only 350 is used as useful work. Calculate its efficiency, right? So what we have is energy. So we're going to say efficiency, it will be equal to the useful energy output over energy input. Multiplied by what? Multiplied by 100%. So what is the use of energy? So the use of energy is, it is able to use just 350 is used as use of energy. So we're going to say 350, that is joules, divided by, what was the energy input? So a machine uses 500 joules. So divide by 500 joules, then we multiply by 100%. So what will be the efficiency? So the efficiency will now be 0 there, 0. Okay, it cancels, joules and joules cancels, we remain with 35 divided by 50. So let's just punch this on a calculator to see the value it will give us. So what is 35 divided by 50? 35 divided by 50, that is 0.7 times 100. So this is giving 70% efficiency. So we can say that this machine is 70% efficient, right? Okay. So let's look at the other question. Explain why no machine is 100% efficient. This is due to loss of energy in form of, we said in form of, some machine are able to lose energy in form of friction, right? When the motion, friction is just the resistance or the opposition to the motion of an object, right? So that is friction. So some machines, due to that friction, they're able to lose energy. Some machines are able to lose energy in form of heat. Some machines are able to lose energy in form of sound. Okay? When they produce sound, energy is being lost as sound energy. So No wonder a machine can never be 100% efficient. Let's look at the next question. That is question D. A light bulb converts 60 watts of electrical power into 12 watts of light. Calculate its efficiency. So calculate its efficiency. So let me use this symbol. So we're going to say efficiency. This is an eta. Eta. That is the symbol for efficiency, okay? So it is like that. So efficiency is equal to, in this case, we are dealing with power. So we are going to say useful power output over total power input. Multiplied by 100%. Now let's do the substitution. So I'm going to say efficiency will be equal to, what is the useful power input? So what is the useful power input? So the useful power input is the useful power output rather. The useful power output is 12 watts, right? So we're going to say 12 watts over, what is the total power input? A light bulb converts 60 watts, so that is the total power input. They multiply by 100%. So what is the efficiency? So the efficiency will be what into what, and what can cancel. We can divide